I see that your work will let go uncovered. Everywhere. मेरे क्लास में नहीं है, मेरे क्लास में नहीं है। तो पहले कौन थे? क्लास से तो थे। तो अभी छात्र हमारे गुस्सा है। मेरे क्लास
Good afternoon. Good afternoon, guys. Am I audible? Am I audible?
Yes, क्या हुआ है?
Good afternoon.
See, my signature is last signature. When you sign the actually signature, so you can take the certificate. So after every signature is finished, you come. Then also alumni card send करना. Next. Yes.
Good afternoon, guys. Hello.
Good afternoon, sir.
Am I audible?
Yes, sir.
Okay. So let us start this session. Last time we were covering the different inversions of the basic kinematic chains. You know that there are three basic kinematic chains. One is the one which consists of 4 turning pairs, okay, which is known as 4-bar chain. Then next is single slider crank chain, and the third one is the double slider crank chain. So we have seen the different versions of the 4-bar chain. Now we are covering the different versions of the single slider crank chain. Okay, in this particular kinematic chain, there is only one slider, and all other links or pairs are turning pairs. Only one sliding pair is there. Okay, so we have seen this in the last last lecture that how is the working of the crank and slotted quick return motion mechanism and why it is called as quick return motion mechanism. So I will share with you its video so that you could have a clear idea about the working of this mechanism. Okay. Just a second. I am finding the video. Can you see the video?
No, sir.
No.
Visible.
Okay. Now it is visible to you.
Yes, sir.
Okay. So see the working. So you can see it is the slider, right? This slider is sliding on this oscillating link. It is your oscillating link. This one is your oscillating link. It will keep oscillating like this. And this is the crank which will make complete rotation. When the crank will rotate about this axis, this piston is free to slide over this. And because of the sliding of the piston over this link will oscillate. And with the help of additional link which are connected to the lever, we will make some use of this oscillating motion of this lever. Okay, so see carefully. Going back or forward. Now it is a backward movement. Okay, so it will give you an idea about how the crank and slotted lever mechanism works and is utilized in shaping machine. Okay, so again I will show you the video of the shaping machine. You will have a more idea about it. Okay. Can you see the video?
Yes, sir.
Okay. So basically it is the same mechanism, right? Only you can see that different components like crank, lever, the sliding member, they are shaped according to requirement. Okay, basically the motion between each and every link is same as we have seen in the basic mechanism. Okay, depending upon our requirement and application, we can give any shape to any link. Okay, so earlier we have seen that the lever which was oscillating, okay, it was solid and the slider was sliding over it. Okay, but here the lever is made hollow with slot and the slider, this particular link is sliding inside of it. Okay, so it is just a matter of application. Different links get different shape, but remember that the motion, relative motion between them will not change. Okay, now let's come back to our PPT. Okay, so we have seen this mechanism. You can see that the forward stroke or cutting stroke has more angle, means cutting stroke takes more time. Okay, and return stroke takes less time. Quick return ratio can be defined by this formula. Okay, let us see the next inversion of the single slider crank mechanism. So examples of these are one, rotary internal combustion engine. Okay, so here in this mechanism, link 2, that is nothing but the crank is fixed. Okay, so you can see the crank is shown here, the one which is between these 2 points. Okay, it is the crank, and this crank is fixed, it cannot rotate. Apart from the crank, each and every other link is free to rotate. Okay, so you know that to crank, this connecting rod is connected, right? This connecting rod is connected to the crank. Then connecting rod is connected to piston at the other end. So this is your piston, which will slide in the cylinder. So this is the cylinder. If you consider it a single cylinder thing, then you will be uh, getting an idea that how the motion is possible. Okay, as crank is fixed, your new rotating member will be the connecting rod. Now this connecting rod will rotate completely. It will rotate completely about this point. Okay, it will keep rotating like this. And as connecting rod is rotating, so piston is sliding in this cylinder. Okay, see what is the form of this cylinder. Number of cylinders are provided, but you just ignore other cylinders and concentrate that there is only one cylinder here. Okay, so as this piston will rotate with connecting rod like this. Okay, so what will happen as it is touching the walls of the cylinder will also rotate with it like this. Okay, So piston will have two motion, that it will slide with respect to cylinder. It will slide with respect to cylinder, and it will turn with respect to connecting rod. Okay, so what will happen, because of the number of cylinders, all cylinders are giving power to the same point here. Okay, so because of that, what will happen, this whole cylinder will start rotating like this, complete, and each and every cylinder there will be firing, combustion will take place, power will be generated, and all these cylinders will all these chambers or combustion will rotate the cylinder like this. Okay, so where this engine uh, used earlier in old days, okay, this engine was used in aeroplanes. Okay, but if you see, which is nothing but the IC engine, but nowadays in aeroplanes IC engines have been replaced. Okay, rotary IC engines have been replaced by the jet engines. Got it? So they have become obsolete. Now they are not in use. Sometimes if you have seen the monoplane, in monoplane you will see one fan is there, which is attached on the front of the plane. Okay, so that fan is run with the help of this rotary IC engine. Okay, whole cylinder of the engine rotates and crank is fixed. Okay, in old movies you can also see these engines in the aeroplanes, fighter planes. Okay, then same is there, which is the Whitworth quick return motion mechanism. It is the same version. Okay, and it is also obtained when you fix the crank. So when you fix the crank, you can either obtain the rotary IC engine, one, and second is the Whitworth quick return motion mechanism. We have seen that quick return motion mechanism is used in shaping machine and slotting machine. Okay, so this mechanism also provides some sort of quick return. Let us see how the construction is like. See, it is the construction of the Whitworth quick return motion mechanism. Okay, you can see this link 2, which is between point D and point C. It is fixed, right? From here to here, this crank is fixed. Same, this is the connecting rod, which is having a piston, a slider connected at the other end, and that slider is sliding in the slot which is present inside the cylinder. So you can say that this AP is nothing but your cylinder. Got it? Now what will happen, as this connecting rod, which is AC, when connecting rod AC will turn like this, okay, about the point C. What will happen, this piston has to turn in the circular path. Okay, as it will turn in the circular path, it is also free to slide inside the cylinder. So cylinder will also turn, okay, like this. Okay, it will so turning point for the cylinder will be point D. It will turn about the point D, and connecting rod will turn about the point C. So you can take any point which is present on the cylinder, say point P, and attach some additional link to it like this. And at the other end, you can again connect some sort of slider here. And to that slider, you can attach the cutting tool. So when it will rotate like this, the cutting tool will slide in the guides. It will perform the forward stroke or cutting stroke and return stroke. Okay, same happens here that in return stroke, the tool retracts quickly, it returns back quickly, and in forward stroke, which is actually the cutting stroke, it takes place at slower rate. Okay, otherwise what happens if you will cut the metal at the same speed or at large speed, it will harm the tool, its life will be compromised. Okay, so here you can see that this angle is beta. Okay, so when your connecting rod will travel from CA2 to P2, CA2 to CA1, during this angle, what will happen? Say when you will, when your connecting rod is at CA2, okay, then your point P will be here, somewhere here. So point P will travel from P1 to P2. It is the P1 and P1 into P2. Sorry, this distance from point P1 to P2 is nothing but the stroke of the tool, cutting tool. Okay, during angle beta, during angle beta, the tool will come back. It will return. Okay, as this angle is small, and during angle alpha, the cutting stroke will takes place. Okay, so when this your point A, when point A is at A1, like this, you rotate it completely here. At that time, the P point will be at P1. When A will be at A1, like this, P will be at P1. Okay, and from the position C A1, when the connecting rod will start rotating, so during the angle alpha, the cutting stroke will take place. A forward stroke will take place. And when the connecting rod will move through angle beta, the return stroke will take place. Okay, so it is called as Whitworth quick return motion mechanism. Okay, if you see the difference between Whitworth quick return mechanism and crank and slotted lever mechanism, you will note it that in crank and slotted lever quick return mechanism, lever will only oscillate. Okay, only what will happen, that connecting rod will uh, rotate completely, as I will show you here. The only connecting rod or which becomes crank. Okay, sorry, in this crank and slotted lever we obtain by fixing the connecting rod. So here only crank will rotate completely, and the cylinder or lever, it will only oscillate like this. But in case of Whitworth quick return mechanism, the driving crank or connecting rod is also rotating completely, and cylinder is also rotating completely. So this is the main difference between these two mechanisms. Okay, understood? Yes or no? Okay.
Yes, sir.
And please type your attendance in chat box in the first session of the lecture only. Okay. So length of the effective stroke is 2 into PD. What is that? This is the PD is the distance between point P and point D. D is the fixed point, and this PD will rotate about it. So if you know this distance, you can find out the stroke will be 2 times of PD, and ratio, quick return ratio, you can find with the help of this formula, that time of cutting stroke upon time of return stroke alpha upon beta. Okay, and using some trigonometry, you can solve the problem on this. Okay, so if time permits, we will take those problems also. So it is about the third inversion of the slider crank mechanism. Now next is hand pump. Okay, so how hand pump is obtained? In this mechanism, piston is fixed or slider is fixed. Okay, so I will show you how the piston is fixed. Okay, it is your slider crank chain. Okay, now what is done? You free all the points here. There is cylinder. Okay, now I am not allowing. I am not allowing to. I am not allowing the piston to slide. Okay, now you consider that this cylinder is free. This cylinder is free and it is pivoted here at this point. Okay, so now you see how the, if you give input to any one link, what will happen to other links, how they will move. Okay, so suppose as this point is fixed, okay, and link 3, which is called as connecting rod, is pivoted here. It is pivoted here, means it can turn at point C. So what will happen? So it is possible to give the motion to link 3, and that motion will be your turning motion like this. You can turn it. So when you will turn it here in this direction, okay, what will happen to the crank and cylinder? See, when you will turn it in this direction, the angle between these two, the link 3 and link 2 will increase, okay, and as the cylinder is pivoted here, what will happen? This cylinder will translate in left direction. In left direction, it will translate. So after some time, what will happen? That this cylinder will come here, somewhere here. It will slide over the piston. Piston you have fixed, okay, and as it is going here, the point B will be somewhere here. Point B is again connected here, and like this, it will be the another position. Or okay, or if you are sliding it in this direction, if you are turning it, then the cylinder will go backward like this in order to match the link dimensions. So cylinder will perform which kind of motion? To and fro motion over the piston. Over the piston. Got it? And we want this to and fro motion in order to say suck the water from the ground. Okay, so how this whole operation takes place in case of hand pump, I will show a video for the same. Just a second, so you will get a clear idea about it. So see how it works. Is it visible, the audio? Sorry, video.
Yes, sir.
Okay, see, if our theory and this practical is matching, okay. So see how the shape has changed. That I want to tell you. We have fixed the piston here. What you can say? This is the cylinder. Okay, you are thinking that it is the cylinder, but now the shape of the piston has changed. See, we have made it hollow and fixed it, and the cylinder which was having a to and fro motion, a reciprocating motion, is now changed in terms of shape. Okay, so now it is having the same motion. What we are interested in is the relative motion of the different components. So here also this link is reciprocating, which was the cylinder of ours. Okay, and at one link, okay, you are giving the angular input to it. Okay, so it will work like this. I will again show you the video. See the motion of links. Okay, so it was the say the final version of this single slider crank chain. Okay, now we will start the inversions inversions of the double slider crank chain. Okay, so you know why it is called as double slider crank chain, because here there are two sliders. Okay, two sliding pairs and two turning pairs. So how to make this kinematic change with two sliders? Okay, so see what is done here. Uh, Here you can consider it as a plate. Okay, so say it is a plate like this, and in this plate you have cut a groove or slots into mutually perpendicular direction. So these are the slots. Okay, in these slots you have provided the slider. So the one slider is here, which is confined to move in the linear direction only in this slot. Okay, similarly you have provided another slider B, which will reciprocate in the slot, or you can say horizontal slot here like this. And these two slots have been connected with each other with the help of this link 2. Okay, so you can see that one there is one this plate, it is one link, in this plate, there you have cut the grooves or slots. Okay. Now what will happen when you will give motion to one point? Say if you give the sliding motion to link 3 or slider, then what will happen? Its sliding motion will be transmitted to the another slider through link 2. Okay. So in this way, you will make it a double slider crank chain. Okay. So you should know that a double slider crank chain has two sliding pairs and two turning pairs. Okay. Then what are the different inversions of the double slider crank chain? Okay. So you fix any one link at a time. Okay. And you give motion to any free link and observe the motion of other links, how they will move. Okay. Then you can use those motions in specific applications. Okay. For example, the first inversion of the double slider crank chain is elliptical trammel. Okay, it is an instrument. It is used for drawing the ellipses. Okay, and in this inversion, which link is fixed? The link that is nothing but your slotted plate. This slotted plate, we have given it the number 4, link 4, slotted plate. Now this plate you have fixed. Okay, now what you will do? Other links are free to have the motion. You give motion to link 3 or say link 1. Link 1 is the slider 1. You slide the slider 1 by some force and observe the motion of other links. Okay. So when you will observe the motion of link AB connecting rod, okay, and link 3 that is slider. So it is obvious that the slider will slide. Link 3 will slide in the vertical path. Got it? In the vertical path. And link 2, that is bar, it will have some kind of rotary motion. Okay. So it is observed and also mathematically proven that any point, okay, any point on link AB, either on link AB or link AB extended like this. So any point on link AB or on its extension will traverse an ellipse. It will make an ellipse. Okay. For example, if you move the slider B from one extreme position, okay. So say it is the left extreme position of slider B and it is the right extreme position of the slider B. So when slider B will be taken from left to right, and again right to left, okay, it will complete its, sorry. Okay, it will complete its one stroke. Okay, so when it will go forward and come backward to its original position, you will observe that any point on link AB, say P, it will make a complete ellipse like this. Its path will be elliptical. Okay, with AP AP and BP as semi-major and minor axis of the ellipse. Okay, it's quite interesting and can also be proved mathematically. Okay, so